This is the Art Geek Zoo Polytechnicast. This is a show where I reflect on my creative projects and topics surrounding them. All right, let's get started with today's episode of the Polytechnicast.
So welcome, and I'm sitting here with a guy I've known for a long time, Craig Andera. He happens to, what's funny is we're going to revisit something that we did ages ago. Craig taught me some modern programming stuff, and now we're going more modern.
Yeah, that was a long time ago. I mean, that was when you were just getting started, and now obviously, you know, you've moved beyond just getting started.
Yeah, I hope so. Certainly, you know, with the change of the technology landscape and all that stuff, I mean, feels like getting started is kind of like a recurring theme.
Well, that was what, 1994? So, coming up on 20 years ago.
Yeah, so it's been a while.
Yeah.
But I don't know. We were talking about monkeying around with the. So okay, stepping back, Craig, you actually are a huge proponent of and big user of this programming language and environment called Clojure, right?
Mm-hmm. Yeah.
And can you tell me a little bit about it, just because we're recording this?
Sure.
So
no, absolutely. So, what about Clojure? Clojure is a programming language, like you said.
Mm-hmm.
It's a Lisp. So, if people have run into those before, it is a Lisp. Lisp is a family of programming languages. It includes Scheme and Common Lisp are the two biggest ones up to now, and Common Lisp is the more common of the two. Clojure is a newcomer. There are lots of Lisps. What's interesting about Clojure is that, in my opinion at least, it is the most modern of the Lisps, in the sense that it has a lot of the affordances that people that have been programming for the last 10 years or whatever would come to expect, right? It just has a more modern sensibility. It's a little hard to go into the kind of the feeling of it, right, as right off the bat, but
because I mean, let's see, we've chatted about it, and it just has sounded like it's been tempting to me to explore, and all of a sudden, just a few minutes ago, we thought, okay, why not just try to jump in and play around to do some? And I thought, well, what the heck, let's make a podcast out of it. And this will be a fun experiment, because I'm curious. I've never jumped in to do the hands-on with Clojure, even though like the ideas of it sound like really interesting. Mm-hmm. Like, we were just chatting off mic about the essentially how state is handled in Clojure.
Yeah, state is a really big deal in Clojure. It's most functional languages handle state differently. Clojure is a functional language. Clojure has an interesting take on that, even for a functional language. But that's a pretty big deal. And
because I mean it's a little bit it's a little squishy and philosophical or whatever. But like I've felt in programming and in designing programs over the years that that a lot of what we hold on to for trying to create a difference between a database does this, and then your code and whatever language you're using to access a database does that, and then there's really separate worlds, or like how objects will have these separate concerns of data and behavior. That to me they're not really different, and all of a sudden you were saying how just one changes more rapidly than the other, one's more volatile than the other, but they're really the same. And then you were saying that somehow that jives with Clojure, and that kind of was like the final straw for me, where I'm like, okay, fine.
Yeah, there's a lot in there, what you just said. And it is certainly true that the whole question of code versus data is something that is very relevant to Lisp, since Lisp treats code as data. It's a little bit different than what you were talking about with respect to...
Which is not surprising to me, because I'm happy to like take a rough understanding of something and then like jump in and then allow myself to be very wrong and then adapt.
So I would say two things about Clojure, right?
Okay.
In terms of should people be interested in it, right? Which I think is part of what we were talking about. I think there's at least two reasons. There are more than 2 reasons for sure, but the 2 reasons I can think of right off the top that people should learn Clojure is that it's a Lisp, right? And Lisps are different. Someone once said, I forget who it was, it may have been Tim Bray, can't remember, said that you should learn a Lisp because it will forever change the way you program, and I think that's true.
Okay.
And it's a functional language, and we can talk later about what that means, but
okay.
I think everybody should learn, every serious programmer should learn at least one functional language as well, because that will also forever change the way you program. It's a very different paradigm. You and I were talking a little bit before about the idea of identity versus value and transitions between discrete points in time as functions, pure functions. Mm-hmm. I know these are all fuzzy concepts for your listeners who weren't in that conversation, but you know, your comment at the time that I wanted to bring up was, whoa, that's really different, right, from what I'm used to, and that's the truth. As I said, honestly, if you know, people come to this and they go, wow, the big deal about Clojure that's different from my usual programming language, say it's, you know, Ruby or Python or Perl or C# or whatever, is that it's a Lisp, right? They're like, wow, you know, all those crazy parentheses, right? If you've ever seen Lisp, yeah. What's the I forget the exact quote. It's something like, it looks like code mixed, or no, it looks like toenail clippings and oatmeal, right? Right, because of all the parentheses.
Right. And
so people are like, oh, it's a Lisp, and that's going to be the big deal. And there's some things there, particularly macros, that people do tend to struggle with as they come in. But the truth is that the Lisp part of Clojure is actually far easier to adjust to than the functional part of Clojure and the way that Clojure deals with state. So while those are both good reasons to learn Clojure, that it's functional and that it's a Lisp,
yeah,
the Lisp one will not be the big deal for you if you get into it.
Yeah, and so I'm curious. Like, let's sort of experiment. Like I have not jumped in with Clojure at all, or honestly with any Lisp. I mean, I've jumped in with, you know, lots of languages. Basic is what I started with, you know, ages ago.
Well, I think we taught you assembly language for a little while, didn't we?
Yeah, then you and I back in '94 we worked on assembly and C.
Yep.
And that was really helpful because you know, as I was, you know, trying to understand how to, you know, put together software and whatnot. Beyond that, it was nice to know like those more underlying concepts.
Right.
And I've you taught me the stack, right? And,
right.
And how the
the idea of indirection is an important one too.
Oh,
like
yeah.
Pointers.
Yep, pointers.
Yeah.
Which, I mean, you can take a lot of that stuff for granted when you're dealing with high-level languages and stuff.
Until you can't.
Right. You take it for granted until you hit a wall, and then you have to be able to see the wall and know how to feel your way around it or work or deal with it some way. And anyway, it's always been helpful to me to somehow be willing to, you know, jump in and learn something new. And there's been Clojure's been this thing now. Like we've been, you know, you know, we're friends and you talk about it.
Yep.
And I've been intrigued for a long time. So I don't know. Let's
sure.
Let's play. Let's see what the heck.
So here we're on Try Clojure, tryclj.com, which is a cool little website that you can just walk up to. You don't need to install anything. You just open it up, and now you can type Clojure. So what are some of the things about Clojure? Let's start with really simple stuff. Well, first of all, what are we looking at here? What we're looking at here is a prompt that is running what's called a REPL, a read. It's REPL, read, eval, print loop. Right, so it's a loop. It's gonna, and it's, you know, there's nothing surprising. Anybody here that's ever run a command line of any kind, it's that. There is some subtlety here. I don't think we're gonna be able to go into it specifically around the read and eval part. But let's just stay simple for the moment. Just type in a number like 1 and hit enter. Okay. And so what happened there was that you entered a string. You know, you type something in and you hit enter, and then it was read. Okay, we'll get to that in a minute. Yeah, so the first one is interesting. Like numbers evaluate to themselves.
Yep.
You put in so numbers are what you'd expect in Clojure. You know, you can type 1, you can type 1.5.
Sure.
What about strings? Go ahead and type a string. Use double quotes. We use double quotes only in Clojure. Okay, so strings evaluate to themselves.
Yep.
Okay. We have some other kind of interesting things. For example, Clojure supports the idea of fractions. So you could type 1/4. Right, and that's 1/4, and it preserves the numerator and the denominator. So you can do math with fractions. We'll get to how you do operations in a second.
Okay.
So that's kind of cool. It's handy for certain applications. Not world-ending, but it's built in. It's nice.
Sure.
What else can we do? We can do what Clojure calls vectors and what most languages will call an array. It's delineated by square brackets. So you could say square bracket 1, and then there's no delimiter, it's just space. So 1 space, 2 space, 3
really?
space, 4. Yeah. You can, here, actually, this is interesting. Yeah, go ahead and do that. So we evaluate that. That prints out, read, eval, print. So it evaluated that text that you typed in, turned it into a Clojure object, and then printed that out. It just comes back as itself. Now, you can put commas in there if you want. Commas are white space in Clojure. They're completely ignored, which is sort of an interesting choice, but it allows you to do this in the situations where it makes you more comfortable. There's actually one place in Clojure where that tends to get used. Notice that they're ignored, right? Because when it reads that in, turns it into an object internally, and prints it back out, the canonical way that it prints it is with spaces as delimiters.
Yep, makes sense.
Okay, so we've got string and number literals. We've got vector literals. We've also got something called a map, which is curly braces, and that's like a dictionary in other languages, or in Ruby it would be a hash.
Right.
So it's just key value pairs.
Key value pairs stored in one.
One thing, yeah, exactly. And you can look them up later. So keys are anything. It could be anything at all.
So what's the delimiter to do key to value? Space?
It's just pairs, just spaces. But if you want to put commas between pairs, you can, because it's white space.
Okay, because yes, all right. So because I'm a big proponent of readable code. So like, is that really like a best practice in Clojure to like just use spaces to do pairs? Because come on.
Right. Most people would use vertical white space, except for very small ones. Interestingly, go ahead and put in something. You could do just 1 space 2 space 3 space 4. Okay, and then close your curlies, and then notice that the default print syntax for this is commas. Right. So the printer. So that thing is text when you type it in. It gets read in and evaluated into an object, and then printed back out. The print syntax for that, it uses commas. Sure,
because it takes a lot of when you're spitting out a text representation of of some kind of object, and you're doing the pretty printing. Is it? I don't know if it's called that or whatever. But Python
slightly different. But
yeah, it's I don't know, or I always think of it as pretty printing, right?
We would call that print syntax. Yeah. Pretty printing is a little different. Pretty printing would, if you had a really complicated object, because you can have vectors that contain maps that themselves contain vectors either as keys or values that contain vectors that contain maps that contain keys that contain sets that contain strings.
Right.
Arbitrary level nesting. Yep. If you printed that out, the default printer just spits it on you, right? You can pretty print something, so that has a specific meaning, right?
So it would then enforce a new kind of white space and carriage returns.
Right, exactly. Make it easier Okay, so this is cool. So we need one more thing here to make maps particularly useful, which is to talk a little bit about symbols and keywords.
Okay.
I noticed earlier you typed in "hey," and it spit in your face, right? It said you can't do that.
Yep.
That's because so the rules for everything we've done so far, with the exception of "hey," are that those things evaluate to themselves. In other words, when you evaluate, when you hit enter, it reads it in, creates a data structure, right? A number in the case of a number, a vector in the case of a vector, right?
Yep.
Creates a data structure. That data structure is self-evaluating. We evaluate it, it is itself.
Yep.
Hey is a symbol, right? Symbols don't evaluate to themselves. They evaluate to something else that we'll talk about later, okay?
Okay.
They point to something.
Right.
There is a special type of symbol called a keyword. It starts with a colon. So if you were to type :hey, that evaluates to itself, right? It is a token, if you like. It's a series of characters that is a symbol, but the rules for evaluating that symbol are return yourself. Now that comes useful mostly, you use it all over the place actually, but one place that you see it a lot is in maps. So you could say, for example, open curly brace, and then you could type :name, and then Rob, right? It would be a string, right? Because the way you wrote it there, it's a symbol. It doesn't evaluate to anything, which is an important point that we'll talk about in a second. And then you could do, just do that. That's fine. You could have more than one, but there you go. Okay. So now, what's nice about there's a number of things that's nice about that. One is that some people just sort of like that. You could use the string name instead. String, quote name, quote as the key instead.
Right.
Keywords have some properties that we'll talk about in a second that make them useful as keys.
Okay.
By the way, the symbology, for anybody that's a Ruby person, the terminology here is a little confusing because in Ruby, that thing with the colon at the beginning of it is a symbol.
Yeah.
And the thing that we called a symbol earlier is a keyword. So the terminology is reversed in Clojure with respect to Ruby.
Okay.
Okay. This is to do with Lisp's history.
Okay.
It's not. In other words, it's not important. It's just the terminology.
Which is again like languages are their cultures.
Right.
So yeah.
Yeah. Okay. So cool. So now we've got. Well, there's one more literal, which is a set, as in a mathematical set. Right. You can do sharp curly brace. So go ahead and do sharp curly brace. Sharp. Sure. The shift 3 pound, if you like, or octothorpe, whatever you want to call that thing over the 3. Yeah. Okay. Octothorpe. Yeah. Anyway, yeah. Sorry, that's just my nerd talking. Fair enough. Then open curly brace. And then just put like one space 2 space 3. Sure, just like that's great. And it's not a map, right? So you don't have to have pairs. In fact, get rid of one of those 2s.
Okay.
To show that we don't have to have pairs. Go ahead and hit enter there.
Duplicate key.
What? Am I completely smoking crack here?
Bam. So, duplicate key 1, is it because I created this object up here?
No,
that's doing some kind
not at all. I'm going to be really embarrassed if I don't use sets. Oh, that is the set syntax, is it not? Duplicate key. Oh, get rid of. That's weird.
So, well, okay. So a set is that, does that imply a set with unique population?
Yes, it does. But anyway. Okay. So learn something new every day. It doesn't like the duplicate keys. It should be fine. It's not illegal to take a set and add another thing to it. But all right. Well, so whatever. There's something going on here that I'm not aware of. So anyway, that's a set. So the idea there is that if we took that and added 1 into it again, it would remain 1, 2, 3, right? There's no duplicates, right? Yeah. It's a set in the mathematical sense. Yeah. Yeah, and notice order is not preserved too, right? So, yeah. Anyway, so sets. So we don't care about sets. The next thing we care about is how do you call functions, right? Because that's...
Exactly.
We've got values, let's have functions. So before we do that, let's talk about one more literal, which is a list. Mm-hmm. Right, so we have vectors, we have sets, which Craig forgot some fine points of, and then we have lists. Okay, so what's the difference between a vector and a list?
Yeah,
a list and a vector are both ordered. Right, in other words, if you say A, B, C, it's A, then B, then C. But in a vector, you can get random access. Right, you can say go to the third thing, and you just jump right to the third thing. Whereas in a list, you have to traverse it. It's a linked list.
A list is more of a queue, or a... kind of.
It's a linked list.
It's a linked list.
Yeah. In a queue, you can take off the end.
Okay.
With a list, it's more like a list could be used as a stack because it's easy to put things on the beginning and take things off the beginning just because of the way it's implemented. But
okay.
So the way that list is important in Clojure as in any Lisp because the syntax you use to write down a list is parentheses.
Okay.
Right. So you go ahead and type in open paren 1, 2, 3, just like we did for the vector, and you can hit enter. We're going to get an error, and the reason is that unlike vectors, where the thing evaluates to itself,
the
REPL read 1, 2, 3, okay, with the parentheses around it, and it said that's a list. It's a list whose first element is 1, second element is 2, third element is 3. But the rules for evaluating lists are, when you evaluate a list, you look at the first thing and interpret it as a function. And you call it with the arguments are the rest of the things in that list.
So are functions lists? Is this what we're getting?
No, functions are not lists, right? No, but you invoke functions. The syntax you use to invoke a function is to write a list and put the function as the first thing, and the arguments is everything else there.
Oh, okay.
So one function that's kind of interesting is plus. So if you wanted to add 2 and 3, you'd say, well, yeah, you can type that in if you want. What is the value of plus? Plus is actually a symbol. When you evaluate a symbol, you get the thing it points to. What does it point to? It points to a function. Okay, it points to the function that adds numbers.
Yep.
So if you want to call that, you put it in a list. So open paren plus, yep, and then arguments 1, 2. Yeah, perfect. Yeah, no, that's interesting, right? What you didn't just choose two numbers, you chose 3.
Yep.
So this is one thing that people first coming to a Lisp get hung up on is this idea of what's called prefix notation, right? In other words, I call functions with the function first and the arguments after it.
Yeah.
People are used to 1 plus 2.
Oh, sure. Well, for math operations, sure, but actually, as far as general calling a function, yeah, I mean that's kind of familiar territory.
It is familiar territory, right? Because
Yeah.
you normally have foo open paren ABC, right? Yeah, so it's very similar to that. The difference is the parentheses on the left of the function instead of on the right.
Yeah.
This is a good point because people get freaked out by this, but as you noted, the syntactic difference, it's not that huge,
It's
right?
not that big, yeah.
Right.
Yeah.
But what's cool here is you chose 3 arguments,
Yeah.
right? But you didn't have to do 1 plus 2 plus 3,
Nope.
right? And in fact, you could even have done plus 1, right? And I wonder if you have any guesses on what that might produce. If you just get rid of the 2 and the 3.
2 and 3. I'm going to guess it's implied. It's null plus 1. I wonder if that would fail. It's 1. Okay.
Yeah, and that's just the way it works. Is that like in many languages, in Clojure you can overload functions based on arity, which is the number of arguments. And there's just an overload of plus that has a single arity overload.
Okay.
Right? There's a 2 arity overload, a 3 arity overload. There's actually an n arity overload. So you can say plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As many as you want, it'll work.
Okay.
That turns out to be super useful because there are lots of times where you don't know how many arguments you have. And it's nice to have sane behavior in the face of that, right? Like just like from a mathematical standpoint. But the other thing that this points out is that, well, let me do this once. What if you wanted to add the result of adding 3 and... So let's maybe do this with minus. So we would do subtract the result of adding 2 and 3 from the result of adding 1 and 2. Or the other way around.
Subtract the result of adding... Okay, so...
yeah, you got it. You already hit the first hard part. So add 2 and 3.
Whoops.
Yeah, or whatever.
2, 3.
Sure.
And then
add 1 and 2 and subtract the numbers.
1, whoops, 2, which I could put a comma there, but...
You could. It would be ignored, yep. Okay, so in other words, 5 minus 3 is 2.
Right.
Okay. Now what's cool about this is I never in my life will ever have to remember, as long as I'm using Clojure, order of operations again. Right? What binds tighter? Times or minus? What binds tighter? Percent as in modulus or subtraction? I can never remember. I did C++ for 10 years. I can never remember. Here, it's always operation, open paren, function, argument, close paren. Right.
So yeah, you've basically you've grouped your operations and you've ordered them, and so you've set an explicit order, and that's that.
You could do exactly, and you can do that in other languages by using enough parentheses. And I always, when I was writing C++, I always put in parentheses because I could never remember.
Yeah, I do that too, even for simple calculations, because I want to make sure that it's I'm very explicitly doing what I intend to do. Because good programs go wrong rather easily with bad.
Yeah, in subtle ways, right?
Yeah, in subtle, exactly. A way that you don't detect until, you've already celebrated releasing it. And, and, you get the bad news. So what, all right, that's cool. What's funny is I did not expect to have that line that we just did make sense yet. Because this is the kind of thing where I'd run into in looking at Clojure examples, and I go, what in the heck is that? But yeah, we built up to it. Makes sense.
So that line is two things. First of all, we've already seen 95% of Clojure syntax.
Okay.
This is really it. I mean, you know these things. You know almost everything you need in order to write a Clojure program, syntactically. Right?
We got to get. Let's see. So the function. How do I make a function? So I see how I call them.
Yeah.
I want to know how I make them.
Yeah. Can we go one more thing here? Because I want to point out here that that let's see, I got the mouse here. That you did something cool here, which is that you composed operations together. So what's the evaluation here, right? Evaluation is I read this thing in, right? So read eval print. That's an important concept. When you read it, what you get is a list whose first element is the symbol minus, whose second element is what?
Second element is the. This is where my vocabulary. I haven't grokked all the Clojure. Let's see. So that second thing is a list.
Yes, that's the important part.
List.
Yep, a list that has 3 elements.
A list, yeah,
exactly. And the third element is a list.
Yeah.
But then what happens? So we've got
then
this
you go inside
recursive,
the list.
exactly.
Yeah.
Recursively evaluate. How do we? When we go to evaluate, we say, well, what is minus? Minus is a symbol. It points to the function that subtracts things. What's the next thing? It's a list. Oh, I need to evaluate a list.
Yeah.
Unlike vectors, lists evaluate to a function call. When you evaluate the list, it's let's look at the first thing. Oh, it's a symbol. The plus points to the function. The function is plus.
Symbol,
Let me get it. What's the second thing? Let's evaluate it. Oh, it's a number. Numbers evaluate to themselves. Done. Third thing is a number. Evaluates to itself. Done.
Yep.
Et cetera, et cetera. It built that. So that's going to evaluate up into 5, which will then be the argument that's passed to the minus, right? And then the next thing is a list that evaluates to the number 3.
Yep.
So I mean, it's there's nothing non-obvious here, right? Like you look at that, and as you say, it makes sense.
But they're fundamental building blocks that you can get pretty complex.
Exactly.
On,
and it gets really interesting when you talk about one of the killer features of a list, like macros, which is that, notice how I talked about, I read this thing, right? So in other words, first I turned it into a list, and then I evaluated it.
Oh, you could have operations that affect what exists to change before it's read?
No, not before it's read.
Okay.
That's something called reader macros.
Okay.
Between read and eval.
Okay.
Sorry, so what does read take in? Read takes in a string. That's a string.
Oh,
right down the screen, right?
No, so read is a symbol that points to a function that you can, or no.
You're right, actually. There is a function called read, but
Okay.
conceptually there's an operation called read.
Yeah.
And what it takes in is a series of characters.
Yeah.
A series of characters is not a list, right? It's really hard for us to talk about this because we as humans look at this and go, that thing is a list. That's not a freaking list. It's a bunch of characters, right?
Exactly, yeah.
So, but you can get inside the compiler's loop and say, well, after you've read it, so after you've turned those characters into a list, I can get in there and go, well, I'm going to switch the last 2 things, or, do whatever you want.
How do you tap into that step?
You write a macro. A macro is a transformation that is applied to the read form of some piece of code and transforms it into another data structure, right?
Okay.
That turns out to be incredibly powerful. The main thing that it gets used for, all sorts of stuff really, but the thing that it gets used for a lot is allowing you to define domain-specific languages. You hear a lot of the word DSL thrown around.
Yep.
Because now, suddenly, you can say, well, as long as what I'm writing looks like a Lisp data structure, I get an opportunity to transform that into some other Lisp data structure that will actually be evaluated, right? So now you can say, well, I'm trying to express a concept. Here's the syntax I'd like it to have. That syntax doesn't really look like this.
Yeah.
But it's conceptually the same thing. It's a transformation that gets you there.
Sure. So, right. So you could work in a language that just that maps to a simpler, more direct relation to your problem you're trying to manage.
Yes.
Right. So you get to work with that simpler vocabulary, which could be, let's see. When I've dealt with this with game engines, like the Jinhanu project, especially, with some. Let's see, domain-specific language. I suppose not in, I'm just kind of throwing this out there, but in some ways domain-specific languages are a little bit like schema, right?
A little bit, yeah.
I would say I dealt with that a lot.
What I would probably say that is that it's like defining an XML grammar for which you might have a schema, right?
Okay.
Right. I might just, you think about Ant or, whatever XML, or what's the C# one?
ASPX, right?
ASPX, yeah. Although I don't think that's well-formed. But sure, it's a DSL.
Yeah.
Right, so this allows you to find DSLs that conform to the Clojure syntax rules. But those are actually relatively flexible.
Okay.
You can go a long way with just numbers, strings, vectors, maps, and lists. And the fact that they nest, right? So you can have all... The one that everyone, at least that I did initially was... No, go ahead. You see people do... HTML.
Okay.
Right, so you might type like square bracket, square bracket, and then so you'd say like colon div, right, and then put a space in, and then open curly brace, and then colon class.
Right.
and then a string that's the value of that.
This is, sure, could call it user info.
Sure, and then close the map, and then a string that would be the next element of the vector. So there's your content.
Sure.
Right, and so this, I mean, this is actually, there's already a library in Clojure that does this. It's called Hiccup, and there's been a bunch of others as well. But you can imagine that this is not actually, by the way, this is not an example of a macro, right? Macros would actually, you would probably pass this to a function which would produce HTML, like an HTML string. But this is a Clojure DSL, right? And it's, as you can see, the language is relatively flexible. It's fairly readable. It's actually more readable than the corresponding HTML because the close tags are less verbose.
Oh,
right. There's no /div, right?
Yep, it is a little less. Yeah, again, languages, cultures, whatever. I mean, obviously, it depends on your experience.
Of course.
But like, yeah, I mean, Markdown, I would say, is probably a little easier than this.
Oh yeah, you're right.
But yeah, but then again, if you're using what you have that's native, like you're building a system out of Clojure, then you may have.
Well, maybe you could have Markdown sections, like right? You could have could have maybe put a map in here that had a key of Markdown and a value of a bunch of Markdown, right? So it's super flexible. I mean, that's really a feature of the Lisp, and the there you go, right? That's a vector, so it evaluates to itself, right? Yep. So, and all the things in it are also self-evaluating, so there's no need to call any functions here. That thing just is its own value. All right, so now you want
a macro and the function. So like that. So I get the existence of the macro. I don't get how I tap into it yet.
Right. I gotta say that's not a 101 topic. Okay. That's something that, at least for me, took quite a while to comprehend. Sure. But the fact that it exists, right? That you can you can write code that looks like one way, and have that actually correspond to a bunch of code that does something an entirely different way. Yeah. That's powerful, right? Because it means that you never, in Clojure, if you don't want to, you never have to write boilerplate code, right? That you copy and paste, because you've got the ability to make a it's macro, like in an editor, right? You run macros to produce a big pile of text that possibly differs in some way. Right. It's the same thing, but it's operating inside the compiler.
That is cool. I'm curious about it, but I can see that. Right. That's not a.
You want to write functions, though.
I do. Yeah, that's like critical.
Well, let's write the plus function.
Completely hands tied here at this until we can.
Yeah, absolutely. So let's write a function that adds two numbers.
All right.
Is that too boring, or do you have a better idea? Or
let's see. Well, no, that'll work.
Okay, great. Yeah,
so two numbers.
So the thing that we need to do is. So remember we said we were doing...
We can do string concatenation or something too. That's
sure, we can do that one, yeah. We'll do string concatenation then.
Okay.
So the thing that we saw was that when we were calling functions, the way it worked was there's a list, and the first element of the list had to be a symbol that pointed to a function.
Yep.
Okay? So the way that we can do that is to use the defn, D-E-F-N, which is short for define function call. So it's a function call, so how do we call functions?
DFN.
You're right, that's right, but in order to call the function, there's a syntax that we have to use.
Okay.
Which is what? We talked about it already.
Oh.
Yeah, you're close, but remember, we're in Lisp now, so...
Oh, yeah. So it's probably this, defn.
Defn. And then what does defn? Takes a bunch of arguments. It takes a name. Call it...
String? Or no, symbol. So I can just do whatever.
It's just a name, it's fine. This thing will be... Yep.
This is Hey greeting.
Okay. And then it takes arguments, which are in a vector.
Yeah, right. Which are in a vector.
A vector, so that's... Yep, exactly.
Okay.
And then you just give them names.
So hey greeting will be first part, second part.
Okay.
Yeah.
Commas won't hurt you, but you don't need them. Yep.
Yep.
And then the rest of it is an expression that is the logic of the thing. So in other words, what you do now is write the code that will be executed when this function gets called.
And that's the next part in this
inside the defn.
List.
Yep.
It's inside the defn.
Yep.
Okay. All right. So
do you want to just concatenate strings?
So what? Print for is okay.
You just said print.
Yeah.
So that's really interesting, right? So so Clojure is a functional language, right?
Yes.
Which means that rather than write a procedures, right? In other words, things that get called that have side effects,
Okay.
like printing stuff to output, writing to files. We prefer, it's not required, like it's not a pure functional language like Haskell.
Okay.
Clojure is a mostly pure functional language. We prefer, in functional languages, to write things that take input and return output. Okay? And I don't mean output in the sense of printing to the screen. I mean return a value.
Just return it.
Just return it, exactly.
Yep.
And since we're in a read-eval print loop, we get printing for free, right? If we call this function, the value will come back.
The
and
result
print
is printed. Yeah.
Exactly.
Okay.
So the thing that does string concatenation already for us, we're going to cheat, obviously, is the stir function, str.
Okay. So, right. So, stir.
Yep, exactly. And then you pass it any number of strings, and it will concatenate them.
Okay. This is going to be pretty easy then. So, first part.
Yep.
And then second part.
Yep. And you could put a literal in between there if you wanted to. All the scrolling on try Clojure is not awesome. But you can put new lines in there because it doesn't... Clojure doesn't care about new lines. I don't think... Oh, well, try Clojure might.
I think it's doing a single line at a time kind of thing.
Okay. It could. I mean, it can actually detect whether you're done with the what's called the form.
Please let me see what I'm trying to type. What I'll do is I will...
Sure, there you go.
All right, so stir, first part, second part, and I was going to put something in the middle. So something in the middle, I could do a string.
A literal, yep.
And then I say...
Yeah.
All right.
Yeah, exactly.
And then
so
we're going to copy and paste this into here.
As an experienced Clojure developer and Lisp developer, I'm highly talented at detecting unbalanced parentheses.
Okay. Did I whiffed the paren?
You did.
Yep, because stir. Okay.
Yep. And I gotta say, this is something that people that don't like, and you know, people have. It's reasonable. People can. Well, that was interesting.
I hit backspace.
Oh, okay.
And I went to a different page.
That's okay.
So,
we're fine.
Fresh page.
That's all right. We haven't done anything that had any side effects yet. This is the first thing we'll do that has side effects, right? Because all that pluses and stuff, it just returned values. So it was pure functional. This, ironically, is not pure, right? It's going to change the environment.
Right.
Right. Meaning now that now the symbol hey greeting.
It's a function.
Points to a function. Yeah. So now you can call hey greeting.
Okay. So hey greeting. Craig is here, and then recording a podcast. How's that?
Looks great.
Craig is here, and then I say recording a podcast.
Right, and then notice that didn't print, right? That returned a value. It was printed by the REPL.
The whole thing is a... So it's because it's the quotes on the two ends of it, basically the function returns a string.
Right.
Which is interesting. It just... so there is a default return value. It's just whatever the final...
Correct.
Yeah.
Yeah, and that's just like in Ruby. Here's the thing, though. This messes people up, and this is not a great place to demonstrate it, but everything in Clojure is an expression, meaning it has a value. Even an if statement.
Mm-hmm.
So if you say if foo x y, meaning if foo is true, then x, otherwise y, that evaluates to either whatever x is or whatever y is. Right? So an if, that's not true in languages like C#, right? Where you say if, and then there's some code that has a bunch of side effects, and those are executed. And then the else, you have a bunch of side effects, and those are executed. But the thing itself does not have a value.
Right.
You can't say z equals if x 3 else 4. Right?
Okay.
You can't do that. You can do that in Clojure.
Okay.
Or in any Lisp, really. Right? Because the if statement itself has a value.
Sure. That makes sense.
Yeah.
Which is obviously, very different than
an imperative language, yeah.
Okay.
Yeah.
Functional language, imperative language, okay.
Yeah, well, I mean, you could argue about the definitions, but languages like C#, for example, or Java. Yeah.
Interesting. And I noticed that this is running on a Java interpreter.
Oh, yeah, we didn't even talk about Java interop. Right. So if you wanted to do it, you can call... So first of all, there's a bunch of interesting things going on here. For one thing, that string, that is java.lang.string. It's not a wrapper around string. It is a Java string.
Okay.
And anything that you can call in Java, you can call from Clojure quite easily. The syntax is actually quite nice. So for example, what's a good... struggling to think of one off the top of my head. Like date time. I think there's a date time in Java. So there's a new operator built in. You could say new, right?
Oh.
And then date time, just the name of the class. It's capital D.
Oh, it's yeah.
It's the Java casing. Yep. Yep, just like that, right?
Yep.
Go ahead, close the paren, and that'll just make a new. Right. I think we forgot to import it. So there's another special thing you have to do called import.
Okay.
This is kind of similar to the Java import, but say import
and then system.datetime.
Yeah, except you got to put a quote before it, and I'll talk about that in a minute.
Okay.
Single quote. Yeah, single quote. So system.datetime, or it's not system. It's
I have no idea.
Yeah, it's Java. I know. I come from a .NET background too. It's Java.lang util. Yeah, Java.util.datetime if I remember right. No. It's actually just the single quote.
Okay.
Yeah, we can talk about that in a second. Go ahead. Yep. Maybe lang, and I could be completely...
Well, and it could be that this try Clojure is crippling that or something. Or,
oh, you might be right. It's sandbox. I wonder if it doesn't let you. So yeah, I always wind up looking up the. But anyway, that's how you pull it in.
You have to do import,
and then you can say new, right? And then what you could do is capture the value of that using something called a def. We did defin, define function. You can also say def. Foo.
So that'd be the reference to the object you...
It makes a new symbol that points to whatever value you associate. So you could do this, let's just say def foo, and then you could pick it like 3. It can be anything, right? So, yeah, like, exactly.
Def foo 3, so def foo, and do I have to do the, or it's just space then?
Yep,
Because defin would then expect a vector.
Yeah, I think earlier I said that defin is a function. I believe defin is actually a macro, but let's not. I just want to point that. But defin actually is a macro that expands to a def form. So it's using the mechanisms of Clojure, and this is how you extend the language. You can say, oh, there's new things in the universe, and they are actually equivalent. Because what you could do here is, can I take the keyboard for a second?
Yeah, please.
There's a function called fn. Yep. Which is a function defining function. It defines an anonymous function. So I can say function of x is +2 to x, right? So what does this evaluate to? That evaluates to a function. Okay, it evaluates to a function that takes an argument and returns 2 plus that argument.
Yep.
And you can actually call this guy just like you would call any other function. I mean, I haven't stored the value of that thing anywhere, so I have to type it again. +2x. So notice the double parentheses at the beginning?
Yeah.
Right? I can take that function and put it as the first element of a list and call it with an argument.
Oh, because the first element in a list is a function.
It's a function. It's either a symbol. If it's a symbol, it evaluates to a function, but that thing is already a function, so, right? So you have anonymous functions. Right, and so why did I mention this? I mention this because defin foo x plus 2x. That actually, the compiler just turns that into def foo function of x add 2 to x. Right, and this is interesting because this is a hallmark of Clojure, to take things that in many other programming languages are one thing and bust them apart into 2 things.
Okay.
Right, now this particular one is common across other lists, but there are places, we could talk about Clojure for weeks, but there are places in Clojure where there are things that are normally bunched together that are exploded like this, right? So in other words, that first form there, that defin foo, right? That's, you see that a lot in other languages. Let's define a new function or a new method or whatever.
Oh, yeah.
Right, and then some logic. But notice that what this really is 2 things. Get the logic and make a function.
Yeah.
Take a name and associate it with a thing.
Right.
Right, those are 2 separate things. And it's actually useful for them to be blown apart. Because there are lots of times where, again, this is not a Clojure-specific thing. Other Lisps let you do this. Other languages let you do this. C# even lets you have anonymous functions. But it's useful, right, to have those two things be separate, and it's powerful. I know I'm kind of beating on this point, but you see this everywhere.
It's a very I mean, I would it's a very Clojure thing. It's you know and obviously coming to it new, I don't have that same appreciation of like, well, this is
45 minutes in, you haven't grokked the whole thing yet?
No.
Yeah, well, 4 years in, I'm still working on that myself. So.
No, but it was cool to actually see the see the parens make sense as a way to order concepts that I'm really familiar with, things like functions and
the syntax is nothing. I mean, if your listeners are thinking, well, I like the idea of getting new skills, but the syntax of a Lisp seems like something I'd really get hung up on, I'd really encourage them to put that idea aside. The syntax is trivial. The semantics, that's the part that's harder to wrap your brain around.
Yeah.
But that's where all the win is, right? Like when you understand why it works the way it does, that's when you've understood something that then you can apply even if you don't use Clojure.
Exactly, and that's why it's useful to learn other languages, because you get a fresh perspective on, like you said, something that's very Clojure is to take something that could be two elements, to break it into the two separate things, and then you could gain more. And I'm totally feeling out here and guessing what would be the benefit of doing this thing that I'm not familiar with yet.
Right.
But you have a new way to parse and play with and understand what you already understand or already think you understand. Yeah.
Object orientation is one. I mean, I don't want to go into it because I think that's too big of a can of worms. But
that is a big can of worms.
It is, and Clojure is not particularly object oriented. We kind of touched on the Java interop stuff.
Yeah.
You can call Java classes. You can create Java classes. You can even create code in Clojure that Java could call.
Right.
Like it would look like a Java class. That's not particularly hard to do.
Right.
But the way you write Clojure code is not the object oriented way, and part of it comes out of that Clojure tendency to explode stuff.
Mm-hmm.
Like if you look at object orientation, classically you hear it encapsulation, polymorphism, and what's the other one? Inheritance.
Yeah, inheritance.
Right.
Yeah.
Those three things in Clojure are totally separate. Encapsulation we actually mostly throw away. Right. Data tends to just live where everybody can see it. Polymorphism is entirely separate from classes. Mm-hmm. There are mechanisms that support being able to select an implementation at runtime.
Well, you mentioned the macro capability. That's
it's not really. No, that's not really it. Macro expansion is I'm pulling the code in and I want to have a terse expression for something that's actually quite verbose or has a different form, right?
Oh, so that's still it's so they're isomorphic in concept. Then they're not really meant to be
orthogonal. You mean? Isomorphic means same shape.
Isomorphic in concept, I said. So maybe not in their structure or the implementation, but you said the macro would explode one thing into a
yes.
version.
I'm sorry. Yes.
So
right, exactly. It's a transformation. Right, precisely. Sorry, I wasn't tracking you there. But there's all sorts of stuff if we're doing polymorphism. Really, really interesting stuff actually. Where polymorphism is I'm calling a method with a name, but I don't know what implementation I'm going to get. Right, that's polymorphism.
Okay.
That is totally separated from the idea of classes.
Sure.
And inheritance is completely separated from the idea of classes and from polymorphism and encapsulation.
Interesting.
And so you can mix and match.
Yeah, and that would be like a lot more serious conversation, I would guess.
That part is not particularly difficult to understand, but certainly it goes beyond what we've looked at here today.
Yeah. Well, I think this is pretty cool.
Okay.
I think this was neat. We got wrapped our head around an intro to Clojure. Lost a few of the beginning examples, but I mean that's how you start any new language. Is you get in and know how to start affecting numbers and strings typically.
Right.
Yeah. That's cool. And then obviously acknowledging Clojure lives inside the world of Java, which I guess you do have access to.
You do have full access to the world of Java, which is super powerful because obviously Java has a gigantic ecosystem. So, you know,
Right.
if there is an open source library to do something, it almost certainly exists in Java, and therefore you've got it in Clojure.
Very cool. And I've felt similar benefit in the world of Python because it's a very batteries included.
Right, exactly. Yeah.
Very rich libraries to tap into. So super cool. I don't know. This was fun.
Yeah, it was cool. I'm glad we got a chance to do it, and
cool.
we've been talking about doing something like this for quite a while.
Cool.
I will say, if I can pitch one thing.
Yeah, please.
I have a tutorial on Clojure, and it actually it's kind of a condensed version of the syntax stuff we did.
Yeah.
But then it also goes into some of the really interesting aspects of Clojure around state management. And you can find that at pluralsight.com, link.pluralsight.com/Clojure. It's like about 2.5 hours of tutorial screencast on the various things that are. It's just a screencast I did on Clojure. 2.5 hours, totally free, no charge at all. I believe you can download it to watch on your iPad or whatever. So
neat.
Yeah, or you can watch it online. I don't know how it's set up right now, but it's been a while since I recorded this, but it's all still valid, and hopefully people find that useful. Yeah,
cool. Well, I'll be sure to include a link to this in the show notes and whatnot.
Cool.
So I guess since we did an actual podcast, this is like a slightly more formal conversation. We would have had more swear words if the microphone wasn't on.
Right, exactly. Yeah, I could kind of drop a few F-bombs if that helps you.
Nah, you don't have to make up for lost time.
Right, okay.
If it comes out natural, that's okay. No, let's see where I was going with that. But yeah, recording the podcast. So like, since whatever, we have this formality of the podcast. So you mentioned plugging this Clojure tutorial on Pluralsight, which is cool.
Yep.
Like what else?
People
can find you on the internet.
Yeah, they can find me very easily at if you Google for Craig Andera, there's only one of them in the world, and I think my name's right there on the screen on the concurrency thing, and it'll be in the show notes, I'm sure.
Cool.
I work at Relevance, which we do Clojure, so I can't imagine that many of your listeners are listening to this for the first time and going, "Wow, great! I need to go hire people." But
totally.
That's one of the things that we do. So
cool. Yeah. Lots of sharp folk at Relevance. So, all right, awesome. And on Twitter, what are you?
Craig Andera.
Craig Andera.
Yeah, Craig Andera, yep.
All right, awesome. Well, cool. Thanks for being here, Craig.
I appreciate it. It was fun.
All right.
Yeah.
This has been the Art Geek Zoo Polytechnicast. Show notes for this episode are available at artgeekzoo.posterous.com. Home base for the podcast is my comic Art Geek Zoo, which is at artgeekzoo.com. To contact me about the podcast, you can email me at rob@artgeekzoo.com. And thank you for listening.